Unit operation classroom, we discuss acceptable project payback period estimation. My name is Shekhar Bhattacharjee. In a certain project, 15% of the total investment is working capital. The minimum acceptable rate of return is 4.95%. That's what the investors want. And the period of evaluation is 15 years. Let's assume this is the life of the project. Which one of the following is the maximum acceptable project payback period? That is when you can just get a return on your investment. We'll discuss this exactly later on. So this is our cash flow diagram. So initially in the 0th year, you can see that we are making a total investment, out of which this is my fixed capital investment. This I is a total investment. FCI is a fixed capital investment. We'll see what it is. And WS is the working capital. Normally, this is recovered at the end of the project period. So this is the working capital. We'll see what working capital is. So this is recovered at the end of the project period. And A is the uniform net cash flow. That means every year we'll be getting this amount, net this amount every year. So they're like 4, 5, 6. So that saying that 15% of the total investment is the working capital. So therefore the working capital is 0.15I and therefore the fixed capital investment is 0.85I. So let's see what is fixed capital investment. Fixed capital investment for a chemical plant, let's say, is the total cost of design, construction, and installation of the plant, which includes land, engineering, costs, contingency, and various other costs. See any standard textbook. So this is what initially we have to invest. Okay. Also, initially we have to invest additional fund, which is called the working capital. This is the additional fund required for starting and running the plant until it starts generating income. What if it could be the raw material, finished product, inventory, spare parts, etc. Again, see a textbook. Okay? And as I said, the working capital is assumed to be fully recovered at the end of the project life. So that's what this cash flow diagram is. Okay. So here is my initial investment, which includes fixed capital investment, which we did just discuss. And then we have the working capital, and this working capital is recovered at the end of the project period. And this is the amount A, which we're getting after deducting all, like say, applicable taxes, etc. That's a total amount which we're getting every year. That's the uniform annual net cash flow. Okay. Now let's see how do we do the calculation. So this R is the total investment. So we do use a present worth analysis. What it is at the end of the limiting condition, the total investment, that means the initially what we're getting, total investment should be the present worth of all project benefits. So here, as you can see, that this is we're getting the first year, second year, third year, so on. So what is the present worth of these each amount what we are the project benefits what we're getting every year? And finally, at the end of the 15th year, when we are getting this one, so what is the find contribution of this working capital realization at the end of what we project life? So we'll be reducing all these values to present worth. That means how much it is worth right now. Because initially we are investing this total investment, which is fixed capital investment and the working capital. So we'll reduce all of these to the 0th time. That means the present worth, and then we'll make the analysis. So I is equal to, that's annual cash flow. That is present worth of A. This is present worth of A at I% interest rate, which is already given at 4.95%, and N is equal to for N years that we're getting for 15 years. So this is going to be N. Okay. And here, the working capital, which is a one-time value, what is the present worth of this value? So this is my working capital value. This F is the future value. F stands for future. That means future what we're getting after 15 years. So what is the present worth of that? Again, assuming this I% return, and N is my project life. Okay. This is the standard equation for A over P, and this is the standard equation for F over P. I is equal to 4.95%. So F is going to be equal to the working capital, as we have discussed, to be recovered in the end of 15 years. And I is equal to, we know, is equal to FCI plus WC. Okay. And working capital is 15% of I. And so this is what we have, it's given in the problem. Okay. So if you do the calculation, I is equal to, you can see what is the return we should get every year. And these values are all known. And this is the working capital value. So once we substitute, these all details are given in this particular website here. So we get the value of A as 0.0890I, which is the minimum annual net cash flow required to achieve 4.95% return is 8.9% of the total investment. That's what it says. So this A every year we should get 8.9% of the total investment I. Then only this becomes sensible. Okay. All right. Payback period is defined as by this equation. What is the fixed capital investment? That means the initial years divided by the average annual cash flow. Fixed capital investment is 0.85I, and A we have just calculated. So we substitute this value, we get 9.55 years. Now the maximum acceptable payback period is going to be 9.5 years maximum. That's the maximum. Okay, with this 4.9% rate of return. So answer should be less than equal to 9.55 years. Since we are given 5, 8, 12, and 15, so we can say, so 12 and 15 out because 9.55 is the maximum. Yes. So A is the correct option. B, that is B is going to be the correct option. Okay. So again, so if we have to reduce this 9.55 years to 8 years, what we should do? We should increase the value of A from 0.90I to 0.10625I. Okay, so that's about 19% increase in A. How can we do that? By implementing higher selling price, higher production volume, lower operating cost, lower fixed capital investment, or better capacity utilization. Now let's look at the practical application of this problem. Let's say a chemical plant is producing an organic dye intermediate. An engineer proposes to install a heat exchanger so that the hot reactor outlet stream can be used to preheat the cold feed stream. We'll see what it is. So let's say this is the cold feed, which has to be fed to the reactor here. So normally what we do, we put to a pump and send it to a heater, okay, where it gets heated to the reaction temperature, and then it goes out, and here the reaction happens, and the product is taken out and sent to the downstream process. What is being proposed that let's make an additional investment of installing a heat exchanger. So what it will do, it will send the cold feed first to the heat exchanger, let's say to the shell side, and it comes out. So that will the heat will be exchanged with the hot reaction. So let's say this is an external reaction, and this is getting, and this is at higher temperature, or there might be some jacket, steam heating, etc. So this is much hotter stream coming out. So that would be used. Let's go to the tube side. So that would be used to heat the feed here. So in this here, so what happens? This comes at a higher temperature, and then it goes to this heater instead of going directly. So that way, it reduces the heat load of the heater. So we use much less fuel here. So then it goes here. So as we say, the product comes out and he exchanges it, and it goes to a product cooler, and it goes for the downstream process. So we have to make an additional investment of getting heat exchanger and other ancillaries. So that will save the fuel cost. So that's what it says, that this reduces steam required in the heaters and cooling water required in the coolers, which is here, cooling water requirement here. Okay, so fixed capital investment is heat exchanger, pump, valves, instruments, etc. And working capital could be additional inventory, maintenance, etc. Okay. So we do that. Let's do a simple payback analysis. Total investment, let's say, is 100 crores. Working capital is 15% of total investment. That's 15 crores you have to set aside. And so fixed capital investment, let's heat exchanger and other ancillaries would be 85 crores. Let's say the steam saving would be 8 crore per year. Cooling water savings would be 1.5 crore per year. Fuel power is 1.2 crore per year, but we have to make additional maintenance. We have to add additional maintenance for maintaining that heat exchanger. Okay, so that is 0.7 crore per year. So the total saving would be this minus this because that's what we have to spend. 10 crore per year. So the payback would be 85 crores per year divided by 10 crores, that's 8.5. So the initial investment of 85 crore is recovered in 8.5 years, so an annual utility savings. So this is just an example. So again, going back here, the correct option that we discussed is this is 8 years. So this correct option B is the correct option.